Welcome back. In this lesson, we are continuing our exploration of the characteristics of science. We will look at accuracy, validity, consistency, and the tentative nature of science. These characteristics help us understand how science works and how it evolves over time. Let's dive in. Accuracy is about getting the right answer. A measurement is accurate if it reflects the true value of what you are measuring. For example, if you use a thermometer to measure the boiling point of water and it reads 100 degrees Celsius, that is accurate because water boils at 100 degrees Celsius at sea level. But if your thermometer always read 102 degrees Celsius when water boils, it is not accurate. It is consistently wrong. Accuracy is important because if your measurements are not accurate, your conclusions will be wrong. Imagine a doctor using an inaccurate scale to weigh patients. The scale might be precise by giving consistent readings, but if it is always 5 pounds too heavy, it is not accurate. Patients may be given the wrong medication doses. So accuracy matters for real-world applications. In science, we need both precision and accuracy. We need consistent measurements that are also correct. Now, precision is different from accuracy. It is important to understand the difference. Think of a target. Precision is about consistency, which means hitting the same spot repeatedly. Accuracy is about hitting the right spot. You can be precise but not accurate. For example, a thermometer that always reads 2 degrees too high is precise because it gives consistent readings, but not accurate because the readings are not correct. You can also be accurate but not precise. You might measure something once and get the right answer, but if you measure it again and you get a different answer, that is not precise. The best situation is when you are both precise and accurate. That is consistent measurements that are also correct. A good thermometer that reads 100 degrees Celsius when water boils is both precise and accurate. It gives consistent readings, and those readings are correct. In science, we want both precision and accuracy. We want our measurements to be consistent and correct. Validity is about whether your experiment actually tests what you think it is testing. Let me give you an example. Suppose you want to test if fertilizer helps plants grow better. A valid experiment would be to give one plant fertilizer and keep everything else the same. same water, same light, same soil, same pot. Then you compare it to a plant that did not get fertilizer. If the fertilized plant grows better, you can conclude that fertilizer helps, but an invalid experiment would be to give one plant fertilizer and more water and more light. Now, if that plant grows better, you do not know if it is because of the fertilizer, the water, or the light. You cannot draw a valid conclusion. So, validity is about designing experiments carefully so that you are actually testing what you want to test. It is about controlling variables so that you can draw reliable conclusions. This is really important in science because if your experiment is not valid, your conclusions won't be trustworthy. Consistency is about reliability over time. When scientists conduct the same experiment multiple times, they should get consistent results. For example, water always boils at 100 degrees Celsius at sea level every time, every place, every scientist. That is consistency. Gravity always pulls objects downward. That is consistency. When findings are consistent, they become more trustworthy. Scientists can build on them. They can develop theories and laws based on consistent findings. But if findings are inconsistent, sometimes one result, sometimes another, scientists need to investigate why. Maybe there is a variable they didn't control. Maybe there is a new phenomenon they don't understand yet. For example, water always boils at 100 degrees Celsius at sea level every time, every place, everywhere. That is consistency. So consistency is important for building reliable scientific knowledge. When we see consistent results across many experiments and many scientists, we can be confident in those findings. Here is something important about science. It is tentative. That means scientific knowledge can change. This might sound like a weakness, but it is actually a strength. Science is open to new discoveries. When new evidence emerges, scientists are willing to revise their understanding. For example, scientists once thought atoms were the smallest particles. That means they are indivisible. But then they discovered electrons, protons, and neutrons. And then they discovered quarks and other subatomic particles. Our understanding of atoms changed as new evidence emerged. The same is true for disease. As scientists learn more, the understanding of what causes disease change. It is the same for the universe. Theories have evolved as telescopes got better and we gathered more data. This willingness to change based on new evidence is what makes science so powerful. It is not dogmatic, it is flexible and open to improvement. So, when you learn something in science, remember, remember that it might change as we learn more. That is not a problem. That is how science works. Science is a process of continuous improvement and refinement. Verifiability means that scientific claims can be tested and verified. If someone makes a scientific claim, other people should be able to test it and check if it is true. For example, if I claim that water boils at 100 degrees Celsius, you can test this yourself. You can heat water and measure the temperature. You can verify my claim. If I claim that plants need sunlight, you can test this by growing plants in light and in darkness and seeing what happens. You can verify my claim. But if someone claims that ghosts exist, how would you test that? How would you measure it? You can't. So that is not a scientific claim. Verifiability is what separates science from other ways of knowing. Scientific claims are testable, they can be verified or falsified through observation and measurement. This is why science is so powerful and trustworthy. We can check scientific claims, we can verify them, we can test them. This is what makes science different from belief or opinion. Now, let's recap the second part of the characteristics of science. Accuracy ensures our measurements are correct. Validity ensures our experiments actually test what we want to test. Consistency shows that findings are reliable over time. Tentative means science is open to new discovery and willing to change based on new evidence. And verifiability means scientific claims can be tested and checked. Together, these characteristics make science trustworthy and powerful. They ensure that science is based on evidence and can be verified by anyone. In our next lesson, we will explore the final five characteristics of science. We will look at objectivity, the methodical nature of science, how knowledge is cumulative, the importance of replication, and how scientists make predictions. These characteristics complete our understanding of what makes science work. Stay tuned. Thank you for watching part 2 of the 14 characteristics of science. If you are enjoying this series, please like and subscribe to our channel. Leave a comment telling us which characteristic you find most interesting or surprising. Did you know that science is tentative? Were you surprised that scientific knowledge can change? We would love to hear your thoughts. See you in the next video.